So next we're going to use an unsupervised learning technique. So unsupervised learning is actually just it analyzes unlabeled data, which includes clustering, association, rule learning, and dimensionality reduction. So it clusters groups similar data points, while association rule learning identifies a relationship between the variables, while dimensionality reduction reduce the number of features while preserving the key information. So there's three: the clustering, the association rule learning, and the dimensionality reduction, and at the same time other unsupervised technique. So why do we use unsupervised learning? So it, it actually can reveal hidden patterns or relationship in our data without actually prior knowledge, compared to this, supervised learning. Supervised learning has a clear, detailed label on it, so we can distinguish each label and all that one. So in this case we're going to try, there are different, unsupervised learning you can choose here. So for this example we're going to try the deep learning. Deep learning is part of a neural network algorithm. So so the deep learning is part of the artificial neural network, which is a model which is based on multi-layered feed-forward artificial neural network that is trained with stochastic gradient descent using back propagation. So we just use this deep learning model like neural network, which is actually good for finding patterns that involve large amount of data, like actually this COVID data set. So what we are going to do is just, again, it's almost the same with the other algorithm. 70% is going to our algorithm. The rest of the 30% will go to our apply model without going inside our deep learning, and the rest, the deep learning, will go again to the apply model. So in here, the deep learning, you can to adjust the parameters as well. So I'm just using mm, the default. You can adjust the parameters to see if you can get a better result in accuracy. So let's run this one. For the unsupervised learning, it may take a little more time. So and at the same time, some unsupervised learning won't get better result as well. So as you can see in this one, if it's showing 100%, something's wrong with our data, or our algorithm is not appropriate. So I think based on our data, uh, if we are seeing 100% class recall, that is something we need to be worried about, because it's impossible it predicted all of those data 100%. So I think it could be the algorithm is not able to identify, or our data set is very limited. As you can see, we only able to run 10,000 of our data set, compared to the 1 million could get a better result if the data was 1 million data set. In our case, we only able to examine 10,000, so I don't think the deep learning was able to catch a lot of the data in it. So let's try another method, which is the PCA, or the principal component analysis. So but in order to do that, we can use our previous model. the decision tree as well. So there are different combination depending on the uh, models that we're using. So for PCA, it is actually under the dimensionality reduction. So which is so PCA, it works by identifying the principal components. So we're going to partner it with the decision tree in this case. So let's try this one. Connect it to the decision tree, and then in here we're going to do the dimensionality here. Basically what it does is that like it clears up like some of the uh, noises in our data, and then before it goes to our split data, and then here again, and then here, and that's it. Let's see the result. So we have an error, so we're going to try and the date type which is not allowed because we got our yes or no in this case. So we can try.